And welcome back. As we go into our next unit here, we're going to go ahead and dive into looking at interfaces and interclasses. But let's first start off with looking at interfaces. So what exactly is an interface? Well, in Java, an interface specifies a set of methods that any class that implements that interface must have. An interface is itself a type, which allows you to define methods with parameters of an interface type, and then have the code apply to all classes that implement that interface. One way to view an interface is as an extreme form of an abstract class. However, as we're going to see, an interface allows you to do much more than simply what an abstract class could allow you to do. Interfaces are Java's way of approximating multiple inheritance. Now, in Java, you cannot have multiple base classes. As we know, we have multiple derived classes, but only one base. However, interfaces allow us to kind of approximate some of the power of multiple base classes. So, interfaces. First off, you have to understand they are not a class. All right, it's a very important distinction here. Even though they will have a .java extension, they are not a class. Instead, as we mentioned, they are a type that can be satisfied by any class that implements the interface. Interfaces are therefore properties of a class that says what methods must this class have. An interface is going to simply specify the headings for methods that must be defined in any class that implements that interface. So let's look at an example one to kind of kick us off. For example, this example below shows an interface named ordered. We have public interface ordered, public boolean proceed, object other, and for all objects of the class O in O2, O1.follows O2 equals O2.proceeds O1. And of course, then we just have a public boolean follows object other. You'll notice in here we don't actually have the full set of code. We only see method headings. There's no instance variables, nor complete method definitions. However, you can and typically will have things such as defined constants. So how do we actually go about implementing an interface? So if I want to implement an interface, a concrete class that is a class other than an abstract class must do two things. First, it must include the phrase implements interface name at the start of the class definition. To implement more than one interface, you simply list all the interface names separated by commas such as implements some interface, comma, another interface. The class must implement the method headings listed in the definitions of the interfaces. So, for example, public class ordered hourly employee extends hourly employee implements ordered. The class must also implement the two methods, therefore, proceeds and follows, as shown in our class ordered hourly employee, which we'll look at here in just a minute. Now, an interface and all its method headings are normally declared to be public. They cannot be private, they cannot be protected, or package access. The modifier public you can omit, but all the methods will still be treated as if they are public. So when a class implements an interface, it must take all the methods in that interface and make them public. Just remember, an interface is a type. It is not a class structure. And because it's a type, this allows us to write a method with a parameter of an interface type, such as the parameter of type ordered, and that parameter will be accepted as an argument of any class that you later define that implements said interface. Now, an interface serves as a function similar to a base class. But again, it is important to note it is not a base class. In fact, it's not any type of class. Some programming languages, such as C++, allow one class to be a derived class of two or more base classes. This is not allowed, though, in Java. In Java, a derived class can only have one base class. In addition to any base class that a Java class may have, it can also implement any number of interfaces. This allows Java programs to approximate the power of multiple base classes without the complications that might arise from using multiple base classes. You might want to say, for example, the argument in proceeds in the ordered interface is the same as the class doing the implementation, for example, ordered hourly employee. There is not necessarily a way for us to say this directly in Java, so we normally would have to make parameters such as type object. And it would be legal to make that argument to proceeds of type ordered, but that's normally not preferable to using object as the parameter type. If you make the argument of type ordered, you still have to handle the case of null and the case of an object that, while ordered, is not of type ordered hourly employee. Therefore, we can kind of think about how does the interfaces work? Well, the interface definition, as I already mentioned, are stored in a .java file and still compiled the same as a class definition is. Now, there is a kind of thing to think about here is with abstract classes. How does that change the game here? Because we said interfaces are kind of like abstract classes. Well, a concrete class or a regular class that we're used to doing must give definitions for all the method headers giving an interface in order to implement that interface. However, you can define an abstract class that implements an interface, but only gives definitions for some of the method definitions given in the interface. The method headings given in the interface that are not given definitions are therefore made into abstract methods. Now, we can also extend our interface. Kind of like how we can derive our classes, we can extend interfaces. So we could derive an interface from a base interface. As I mentioned, this is called extending an interface. And the details of doing so are very similar to how we would derive a class. We usually use that keyword extends. Now, one pitfall to kind of keep in mind here is that interface semantics are not enforced. As far as the Java compiler is concerned, an interface has syntax but no semantics to worry about. So, for example, the definition of the order interface says the following in a comment. For objects of the class O1, O2, O1.follows, O2 equals, O2.proceeds, O1. Now, you might just assume that this is true even if there were no comment in the interface. After all, in the real world, if we think about it, if I precede you, then you have to follow me. However, that is giving your intuitive interpretation of the word precedes. As far as the compiler and runtime systems are concerned, the order interface merely says that the methods precedes and follows each take one argument of type object and return a Boolean value. The interface does not really require that the Boolean value be computed in any particular way. The compiler would actually just be satisfied if both precedes and follows always return true, or if they always return false. That's all it really cares about. It would even allow the methods to use a random number generator to generate a random choice between true and false. Now, it would be nice if we could safely give an interface some simple semantics, such as saying that O1.follows O2 means the same thing as saying O2.proceeds O1. However, if Java allowed that, there would be problems with having a class implement two interfaces, or with having a class derived from one base class and then implementing an interface. Either of these situations could produce two semantic conditions, both of which must be implemented for the same method, and those two semantics, therefore, may not be consistent. So as that contrary fact, for example, you could require that O1 follows O2 means the same thing as O2 precedes O1. You could define another interface with an inconsistent semantics, such as saying that precedes always returns true, and that follows always returns false. As long as a class can have these two objects, there's no way a class could implement both of these semantics. Interfaces in Java are therefore very well behaved, and the price of that behavior is that you cannot count on Java to enforce the semantics within an interface. If you want to require semantics for an interface, you can add it to the documentation, as illustrated by the comment that we saw in ordered and showably ordered, but just remember that these are just comments. There's no way to actually force it in. You can suggest that so that the program understands how these interfaces work, but again, they're not going to be forced to. Neither the compiler nor the runtime system are going to do anything about it, because again, remember, it's a comment. So you can't rely on the semantics to be followed. However, because we live in an imperfect world, and sometimes you find that you have to specify semantics for interface, you want to do so within that documentation. Again, put that comment in there so the programmer knows exactly how it's going to be used, and therefore it becomes the programmer's responsibility to make sure that they follow those semantics. Now, having made the point about interface semantics not being enforced by the compiler or the runtime system, it's important to nonetheless follow whatever specified semantics are specified for that interface. Software written for classes that implement an interface will assume that any class that implements an interface does satisfy and meet the specified semantics. They're going to assume that you can follow those directions. So if you define a class that implements an interface but does not satisfy the semantics for the interface, then software written for classes that implement the interface will probably not work correctly for your class. Now, when you define a class that implements an interface, the compiler and runtime system will let you define the body of interface method any way you want, provided that you keep the method heading as is given in the interface. However, should you follow the specified semantics for an interface, whenever you define a class that implements it, you're going to be in good shape. Otherwise, the software that you write may not work for your class. And let's go ahead and take a real quick look at how we can see those interfaces. You can see here in Eclipse, I have a public interface ordered. Here's my Boolean methods right here. And you notice one thing also to point out here, when we are working with these method headers, you notice that there is no curly braces here. All right, these are semicolons. Same thing here if I look at showably ordered. You'll see that it extends ordered. So this is, of course, the way we can derive this. So just as this is a kind of base interface, this is an extended of one. So I can do public interface showably ordered, extends ordered, and then of course have public void show one who precedes. And again, just a real quick way to do that. Now, if I want to see how these actually get implemented, if I look at order hourly employee, all right, you can see that it extends hourly employee, which implements ordered. And so that means this is a derived class of hourly employee, but it's also implementing the ordered interface, which means it needs to have this precedes and follows object, because those are what's required here from this interface. If we go and look at the myAbstract class, you can see this one is also implementing ordered. And you can see again, we have a precedes method here, and then we have a follows method. Now notice the follows method is not actually defined here. All right, because why? Because this is an abstract class, so we just have to make sure we put this abstract modifier here in order to make sure that that condition is satisfied. If I took out the abstract in here, we are going to get an error because, again, we are saying we're going to explicitly define what that method is doing. But we leave it in there, we have an abstract method. Now, the last thing to show you is if you want to go and create your own interfaces, because I didn't quite show that yet, if I'm in my Eclipse folder, for example here, I can right click and I can do a new, and instead of creating a class, we want to go one further down and create an interface. Because remember, the big thing to keep in mind here is that these are not classes, these are interfaces. So when I click on interface, we're going to get a simple window here. So let's just call this my interface. And when I create that, you will see it creates a public interface, my interface, and then inside of that, then we can do whatever methods we want to create. So let's just say I create a method, and again, if you look at these, we have Boolean methods here that, of course, you can do voids. I'm just going to call this public void my method. And I'm not, if I do a open close curly bracket, you'll notice it says abstract methods do not specify a body. And that's because interfaces kind of have that same behavior as abstract. So we're going to change it to a semicolon, and then we would have to add in here preferably a comment of some kind that gives documentation. Now I'm not going to worry about what this method does right now because, again, I'm just demonstrating how we can create this. So of course, in a proper one, you'd want to make sure that you have a method here with a comment that describes what's that doing. Now, this one, of course, is one single comment, which you could use. You could split that up so you could have one for precedes and one for follows. Look at showably ordered. You can see, again, we have one comment that describes this method. And I could very easily come in here and add description of whatever I want my method to do. But that's how, of course, I can create an interface. And then if I want to use it in my class, just remember we have to use implements. So if I wanted to, for example, say implements, let's say my interface, I can just put it in here. So my interface, hit save. Now, of course, you'll see I get an error though, because right now I don't have that interface implemented. So let me save that real quick. And so all I need to do to satisfy this is say public void, and it was my method. open close parentheses. And you can see now it is satisfied because I have gone in and added the conditions that are needed for this to work.